Alrighty, good morning everybody. Hello, thank you for coming. Day 2. Everybody settled into this glorious weather and time zone? If you saw the OpenStack user survey, Ubuntu continues to be the platform that most production OpenStack runs on. And of course that comes in all sorts of shapes and sizes and flavors and colors and variations. So we have visibility on a lot of different OpenStack projects, a lot of different approaches to OpenStack. And so the format we wanted to use this morning was essentially to distill and sort of summarize what we've learned looking across all of those different projects. From the perspective of somebody who essentially is kicking off an OpenStack initiative or in the middle of an OpenStack initiative, just to sort of level set in terms of what we have seen working in the field. And then we wanted to pair that opinionated view with contrasting opinions or alternate opinions or complementary opinions from some of our partners and customers who have spearheaded initiatives of their own. So you'll see a view from Canonical effectively, and then you'll see a view from a different organization. I'm lucky enough to be joined this morning by Florian Haas. Florian is very well known in the OpenStack community over many years. He led an independent consulting, really an authority on the OpenStack landscape. And today he's in fact, I think this is the first time you're publicly engaged on behalf of City Networks. Hastexo was acquired by City Networks, a Canonical customer that operates a public cloud focused on regulated markets. Is that right? Yeah. So in Europe and elsewhere. Okay, so I'm going to distill a couple of key thoughts. Now, I'm a technologist. We're all technologists. We love the technology. The technology will not determine whether or not your OpenStack succeeds or fails. From a technology point of view, you are in a very large ship effectively, and the stuff that you might do, the opinions that you might have, the changes you might bring to bear are going to be a very, very, very small percentage of the total picture. There are, in fact, if we look across all of the OpenStack projects we've had visibility on, there are really two fundamental gates you have to get through. One is an economic gate, and it's not something that technologists like to think about, because you tend to, the body language that we tend to see is people feel like the institution is backing them with whatever it takes to go build a cloud. But at the end of the day, we have seen projects ultimately fail because they didn't pay attention to the economics of what they were building, right? And the economics of what you're building are often complicated, but you are subject, almost every cloud is subject to an evaluation against two alternatives. One is VMware, which is known, trusted, loved and hated, right? But fundamentally it's known, and it represents, for the institution, it represents an understandable cost profile for running a VM, right, or a virtual disk. And of course, the emerging public cloud marketplace, which again gives the institution a very clear reference set of economics or perceived reference set of economics for a VM. And if one doesn't pay attention to this, you can easily end up in a situation where the business doesn't buy from the cloud, even if the cloud gets built, even if the cloud has some interesting capabilities, even if people are tremendously proud of the work that got done or it was good work, the business tends to sort of take a business decision about what the operating cost is going to be for a VM. And those two gates are just not things that one should avoid. The second gate is the health of what gets built. Because OpenStack is complicated and moves quickly, you can go down a million different paths in building an OpenStack. There are a million different architectures that you might adopt. There are a million different things you might emphasize, things you might try. At the end of the day, your ability to upgrade that cloud and expand that cloud and scale that cloud on demand will be central to the way the business feels about the cloud that you built, right? So standing it up is one thing. Standing it up and then being able to respond to people saying, I have a new project, how fast can I get more capacity on that cloud? Or my developers want the newest version of OpenStack. There's some new APIs in there that are relevant for us. Can you deliver that? Those two things, if you're unable to respond to those, then essentially it results in a stuck stack, a cloud that is perceived to be unhealthy. And that's not a place anybody wants to be, right? At the end of the day, you've got to survive these two tests. And those lead to a set of choices that require sort of some discipline and diligence, effectively, on the part of people who are going to be project owners. So the biggest killers, consulting costs. The most dangerous thing we've seen organizations do is go in and say, look, all I need here is a bunch of consultants to help me stand this thing up. And the reason for that is very simple. Your cloud on day one is going to be the smallest it's ever going to be, and therefore your overhead cost divided by the smallest possible number of VMs that you're going to run on day one. If that number looks really, really bad, then your project will get killed, almost certainly. And we've seen cases where millions of dollars got spent on consulting to stand up a 20-node cloud. Now, that sounds extreme, but it's a fairly common occurrence because often these projects are seen as being very strategic, and so everybody wants a piece of it. You've got to add up the cost of that, right? Somebody somewhere is going to add up the cost of that. And so, that's something to think about up front. There's obviously depreciation and hosting. What that really leads you to is thinking carefully about how you purchase hardware, what hardware you purchase, and how you organize that. There are integration costs. Again, that leads you to be very careful about a set of promises that you might make or capabilities you might explore. There are automation costs, Chef, Puppet, Ansible. There are code, costs money to write and maintain code. So those are things to think about. And then ultimately, there's ops headcount. Okay, so I talked a little bit about minimizing consulting overhead. It is probably the most important thing to get right up front. Now, there are some exceptions, right? If you absolutely know, if you're AT&T and you absolutely know this thing's going to have tens of thousands of hosts, then it may make sense to essentially, at the get-go, be investing in custom architectures and operations frameworks and so on and so forth. But even under those circumstances, you may want to think carefully about your messaging to the business internally. On the hardware front, we've learned to essentially try and make this easy for people. If you ask us, we can give you essentially a reference SKU from each of the major hardware providers, Dell, HP, Supermicro, Quanta. We could stretch that to Inspur, Lenovo in the Asian market. And really, this boils down to thinking about, again, your net economics per VM. There is a long tradition in many IT departments of thinking and expressing opinions around hardware and what hardware is the right hardware for a workload and so on and so forth. There's also a lot of pressure from the sell side, effectively, to shape hardware choices and to tailor those to particular applications or use cases. You won't find the public clouds going down that route. You know what I mean? They have a very economically driven framework for buying hardware, and the businesses that follow that framework end up essentially in a much better place from the point of view of their aggregate economics. You may think that you're building a specialized cloud. This is a big mistake we see people making often. They say, well, I'm building a cloud for transcoding, or I'm building a cloud to run databases. But a successful cloud eats all the other clouds. Like if you think of multiple clouds getting built in a large institution, the one that works best is the one that attracts more workloads. The more workloads it attracts, the less specialized it becomes. So the best path to success, effectively, is to think about this from the beginning and be general at the get-go. Today, we're recommending that people essentially maximize RAMs. You want to make sure that you're using all of the memory bandwidth effectively, and you should look at the economics of the RAM that you're buying. 2U2 socket is a standard form factor, directly attached storage. It makes very little sense to be integrating legacy storage into a private cloud environment. You'll do much better by essentially engaging with developers around modern software-defined storage and building a portfolio of workloads that love your capabilities than essentially trying to build that bridge to the past. VMware does that just fine. Hierarchical storage acceleration is a key ingredient. So using Bcache to essentially provide both fast and cheap storage and understanding how to do that very efficiently, I think, is really important. And then very aggressively getting access to the commodity high-end switching that the public cloud providers are driving, right? The market for 50 gig, 100 gig white box equipment is very substantial now. There's a lot of investment from providers in there. It's not traditional networking, but it does wonderful things for your economics. And then containerizing the control plane so that you have access to essentially compute everywhere. You're not segmenting your initial smaller cloud into administrative zones effectively, and then compute zones. You can argue that every cycle effectively is working. If it's not working, then you're paying for it. Automating the hardware. Now, we have an opinionated view on this, and it's a view that I think is now becoming quite widespread. Metal as a service, MaaS, is lean, mean. It essentially does what it says on the tin. It gives you machines on demand. It understands the low-level, prickly things that you need to run, essentially the physical infrastructure in a data center. And the pattern that we see emerging is that people will essentially run the entire data center on MaaS, and then they'll give a slice of that data center to OpenStack. There are lots of things that people are realizing they want to do next to OpenStack. It might be containers on bare metal, whether that's Docker or Kubernetes. It might be machine learning, AI. It might be big data. It might be HPC of various forms that they traditionally were doing on bare metal and want to stay doing on bare metal. And it's a lot easier to do that when you essentially have a programmable infrastructure. So MaaS is being used at very large scale. The biggest users of MaaS are actually people who you would think of as public cloud companies, so companies that you'd think of as customers of the public cloud and having been born on the public cloud. Of course, what's happening is the economics of rental compute are becoming clear, and so they're trying to create a hybrid dynamic, and we have good visibility on that. We work a great deal on the public clouds. Most of those guys are on Ubuntu to a large degree, and so we have visibility on what they're trying to do in a hybrid environment. And so they're looking for the same experience that you'd have in a cloud from an ops point of view, but they're looking for that with bare metal. And so a lot of gaming companies, telcos obviously have reason to be on bare metal, and then a lot of people who do sophisticated stuff with software, again, typically need access to underlying bare metal capabilities. You probably know what these are. This is a half rack effectively. 11 little Intel microservers, one as a control plane running MaaS, and then the rest are essentially dynamically allocatable to any sort of workload. I think we have on this one, I have OpenStack up and running. Actually, I don't have the MaaS dashboard. That would be fun. Let me go get that. What is it, 80.1?
Yes.
And what's that? Old Faithful. So here you see the nodes effectively. There are folks running this at a scale of tens of thousands of nodes. The architecture of MaaS essentially is hierarchical. There are rack controllers that effectively provide local services inside the rack, and then there's a region controller, both of which sort of natively do HA. So DHCP, DNS, IPAM, PXE, all of those things are automated in this way. So you can see a bunch of the machines are running, and if I switch to this view, I can just I can show you that that's OpenStack running in a modeled fashion with Juju, and then you can see the mapping to machines effectively, and those machines are what got pulled out of MaaS. So automating the bare metal allows you to do very, very fast test and dev and operational experiments effectively. Try an architecture of OpenStack, stand it up. It takes 20 minutes to stand it up, evaluate it, tear it down, make some changes to the code effectively, stand it up again. And that is the fastest way to learn what architecture is going to work best for you. If I wanted to deploy Kubernetes on this, I've got nothing going on over there. If I say, is that right? There you go. I'm essentially bringing in a model to an orchestration environment called Juju, and that's mapped to this cloud, which is the bare metal cloud. And so it's essentially pulling in the operational code, and then it's going to stand up a couple of machines. You'll see some lights coming on effectively. Those machines are getting switched on. The right operating systems are getting deployed. Once those are ready, they're handed over to the orchestration framework, and we'll have a Kubernetes up and running in no time at all. Let's come back to this. Okay. Limit your scope. There are a ton of things that exist under the OpenStack umbrella. and they all sound interesting and good, and they've got people pushing them and promoting them and so on. The reality is success or failure hinges on your ability to deliver on-demand infrastructure. And being able to land that and get the developer engagement with that is the number one priority. Your enemies are time and money. Effectively, if it takes too long to get developers engaged, then you're often in trouble. If it costs too much to get developers engaged, then you're in trouble. So limiting scope effectively is the easiest way to essentially time box that whole exercise. And then Kubernetes has emerged essentially as a multi-cloud glue layer for application developers. So I would add Kubernetes to the mix, so that you effectively are able to say to your developers, look, I'm going to deliver you a Kubernetes, and I'm going to deliver that on bare metal and on VMware and on OpenStack and on public cloud of choice. That way, effectively, your developers are starting to engage in a world that you can participate in from the get-go, rather than essentially having them engaging in worlds that are very difficult for you to participate in the public cloud, where they lock themselves into specific APIs that aren't going to exist. So that aren't going to exist in OpenStack. So that's why Kubernetes is a very useful primitive to essentially get in. Again, which Kubernetes and how that Kubernetes is done, I wouldn't invest any time at all in trying to be a better Kubernetes than upstream Kubernetes, because upstream Kubernetes is going so fast that just keeping up with that and having a framework for operations which gives you clean upgrades and so on and so forth is the most valuable thing. We do that. I saw, I showed you the way we would build. Let me just have a quick look at that. So that's that Kubernetes coming up on bare metal. It's only across 2 machines, so I'm going to go scale that out. So now you can see I've allocated a bit more hardware to that Kubernetes worker function effectively, and you'll see a few more lights come on, and that's what it feels like to operate Kubernetes in a model-driven way. I can do exactly that same thing on top of OpenStack. If I say I've got a second orchestration controller running on top of that OpenStack over there, I can say I'm going to create a new model. Now that OpenStack is running in this dashboard, so I just have to log into Horizon probably. Oh, there we go. So there's that Juju controller effectively. If I go and say, I don't think I need this bit. I'm going to use a slightly different Kubernetes model just because I'm on a virtualized environment, so that's a bit more interesting. Right, so you saw I used basically exactly the same operational framework, and I'm now building a Kubernetes on top of OpenStack. It'll take a minute or two to get going, but then you'll see those instances spinning up. On top of the OpenStack. So none of this is particularly complicated. You see, I haven't done anything fancy, but you can also see how engaging that is for developers, right? You are essentially giving them something they can work with. And that's really the key, is to get this dual track, your own operational story going and your developer story going. If you tell the developers to wait, they won't wait, they'll go somewhere else effectively. In terms of architecture, if you're going to be less than 200 nodes, you will almost certainly get better economics if you use a managed service. Typically the average business that has 200 physical machines today has a bunch of ops capability for the apps running on that. And we've seen a lot of organizations put themselves into a super stressed position by essentially trying to operate an OpenStack under the hood as well as that same quota of applications. So you're just much better off going to a managed service. At less than 200 nodes, the costs of that will be significantly less than 24/7 headcount to operate an infrastructure, and the risks less too. North of that, up to about 4,000 nodes, again, you should probably stick with a reference architecture, because a reference architecture is going to give you a better upgrade posture, although you probably want to self-support. You essentially want to operate that yourself, although keep to a reference architecture. And only if you're north of about 4,000 nodes does it really make sense to start investing in the kind of capabilities you'd want if you want sort of deep developer engagement. Okay, so these two parallel tracks, even if you're going to be north of 4,000 nodes, If you're not going to be there within 2 years, you should start with a managed service and then graduate effectively to operating that architecture, that reference architecture yourself, and then graduate, well, at the same time, invest in the capabilities to build your own operating framework. But I see some people in the audience who have built their own operating frameworks. I think they'd agree it's a multi-year exercise, right? It takes time to build. And during that time, you don't want to be losing your developers and your workloads. Okay, I don't want to spend more time on this. This is essentially just using a model-driven operation story. That is the only way to avoid getting stuck in the weeds with operations code, right? Historically, everyone wrote their own operations code. So things like Puppet and Chef don't really have this idea of packaged, reusable, encapsulated operations code. And people often don't understand what that means, but what that really means is that everything is a fork. And when everything is a fork, everything is a snowflake, and you get stuck, effectively. Folks who have gone down this road, essentially who have used traditional ops code, find that they end up having to learn everything and reinvent everything themselves. So use something model-driven and create this capability for yourself. In the end, this is the architecture that most of the people that I think have been very successful converge on. They're using MAS for the physical provisioning layer. Ubuntu is a common currency effectively on top of that. Kubernetes on bare metal is very interesting. There are a ton of low-state workloads like machine learning and so on that fit best in that kind of construct on bare metal. And then OpenStack with Kubernetes on top of that. Okay, at this point, I'm going to invite Florian to come up. And Florian, if you want to introduce yourself while I switch to your deck.
Okay, good morning.
There you go.
All right. Good morning, everyone. My name is Florian Haas. I'm the VP of Professional Services and Education at City Network. As Mark said, I was the founder and original CEO at Hestexa. We were acquired by City Network about a month ago, and I'm going to take this moment to tell you just a little bit about what it is that we're doing at City Network. We are a whoa, sorry about the feedback. That's not the kind of feedback we like on stage. We are a public cloud provider. We run a global public cloud that is based on OpenStack, that runs on Ubuntu. But that's not the only thing that we do. We also provide private cloud services and professional services around private cloud, and specifically what we're doing there is what we call industry cloud. That is OpenStack optimized for specific verticals. And the specific verticals that we're talking about here are largely the financial industry, but more broadly speaking, anything that requires regulatory compliance. So that's a sort of a strong suit of ours. So that's the kind of thing that we do. This is all, as I said, based on OpenStack. I'm not going to go into that in a whole lot of detail because I'm sure you're all very familiar with that. We currently operate 8 regions worldwide, and we are continuously building more. We just recently opened a region in the UAE. And like I said, we have others in the pipeline as we go along. We're also an OpenStack Foundation Gold member. This is kind of the important part. This is the kind of stuff that we do and that we excel at, which is all these rules and regulations and certifications that you have to abide by in a computing environment. We help you comply both on public cloud and in your private cloud as it relates to and built into your hybrid cloud strategy. So that's kind of the strong suit that we put forward. Now, just a few words about how the infrastructure runs, how the infrastructure operates. Like I said, it runs on Ubuntu. Mark encouraged me earlier to also present sort of alternate views on how to do deployment. with OpenStack or on OpenStack. As it happens, we're not deploying our stuff with Juju. We do run MAS, but we don't deploy our stuff with Juju. Instead, we are standardizing on OpenStack Ansible, and that works just as beautifully on Ubuntu. And that enables us to build our stack on the same kind of feed from packaging and so forth that we can consume there from Ubuntu, and that makes us very happy. And also on the Kubernetes side of things, on the container orchestration side of things, we are very familiar with the way CDK works, so the canonical distribution of Kubernetes, which Mark just demonstrated. I'm hoping there's actually going to be something interesting coming out of Canonical to that effect shortly. The approach that we're taking is sort of the even more upstream-based approach with Magnum. And if you're interested in how that operates and how that works, I do have a hands-on session on that tomorrow at 9 a.m. and that talks about deploying OpenStack Magnum with OpenStack Ansible on Ubuntu in a hands-on fashion. Right, and that's it. Thank you, Mark.
All right, thank you. Got it. Okay, so two different views of operating. One centered on sort of public services, one centered more on internal cloud capabilities. We have time for questions, and I think Florian would be happy to take questions as well. So please direct them to both of us. I just want to pop over to those others. Come up, Florian. I just want to pop up to those two deployments and see what's going on. There are our Kubernetes instances coming up. I can switch back to that model. You can see essentially it's still building. So these various components are talking to each other and essentially establishing a consensual view of the world. Looks like it's just about done. And if I go back to the bare metal world, we have the same thing there. I'm still waiting for a container to come up, but that's normal. That would come up once everything else is done. Okay, any questions? Yes, hi.
Could you talk more about why you talk about doing both bare metal and Kubernetes inside of OpenStack?
Sure. Kubernetes, people have, when something's new, you get a lot of excited opinions about it. And it takes a while for people to get a handle on what something really is and what it's really good at and what the zen of the thing is, how best to use the tool, right? So in any new tool that comes out, there are people who essentially want to recompile their kernel with that thing, like let's recompile the kernel with LLVM, right? Kubernetes is a little bit like that at the moment. There are some people for whom it is the only hammer that you need, and you need one hammer. And so that gets them to a place where they say we should have an institutional conversation about which container framework we should use, and we should build one container framework for the whole institution. And I guarantee you, everybody who's going down that path is wasting time. You should really think about Kubernetes as a message bus, right? It's much more like ZeroMQ or RabbitMQ than it is like OpenStack, right? It is not the new OpenStack. It's a framework for developing and operating distributed applications. And it's great in that sense. But you have all these weird intercouplings between your app and the Kubernetes that it's running on. And so what that means is that if you tell developers that there's only going to be one for the whole building, you create a massive problem because they can't agree with each other on which one that should be. People who built an app using Kubernetes 1.6 don't really want to get told that they have to use 1.8 because the building decided it's going to be on 1.8. And conversely, people who are starting an app now don't want to be told that they have to use 1.6 because it seems old and deficient to them. So you really want to think about that as an application-level construct. And where it's very useful is as an application-level construct that abstracts clouds. So you can essentially say, look, start your development process. You can work on your laptop. You can build Kubernetes on your laptop effectively. LXD containers. There was a great presentation on that by IBM at KubeCon. So you get a full Kubernetes environment on your laptop, and off you go build your application. And then that application will drop onto Kubernetes on any cloud effectively. And you also essentially decouple the upgrade process app by app So when this app wants to move to Kubernetes 1.7, they can move to 1.7, and that app doesn't have to worry about it. So that's why essentially you should think about Kubernetes as something that you create dynamically for a project effectively and then curate with that project in conversation with the people who are developing there. It's much more like a message bus than an infrastructure as a service. Yeah.
I'd like to add one thing on that one, which is if you're wondering how should I be deploying my Kubernetes, what Mark's mentioning, it may be one of the things that influence your decision of whether you're going with CDK or whether you're going with Magnum. Mark mentioned versioning, and as it happens, Magnum basically drops, or at least defaults to dropping a specific Kubernetes version into your system, depending on which OpenStack release you're deploying Magnum from. Whereas with CDK number 1, you have the ability to essentially run your own Juju deployed Kubernetes in any OpenStack tenant and any OpenStack project that you own, and CDK tracks upstream more closely. So just as an example, in OpenStack Pike, we are at Kubernetes 1.7.4 with Magnum, and CDK is now beyond 1.8. So it's just a point that might influence the decision of what you're going with.
With CDK, you can say deploy 1.6 or deploy 1.7
That's
or
true.
deploy 1.8 or upgrade from 1.6 to 1.7. So each of these little bubbles effectively becomes a little operated bubble of Kubernetes, right, for that application. One per tenant or project, exactly so, yeah. And
But
that works
you're
on
also-
VM
sorry.
where it just essentially lets you unblock your developers in a slightly more healthy way.
Just wanted to point out that you're also tracking upstream more closely in this case with CDK than OpenStack.
That's right. The
Yeah, you're faster.
binaries in the canonical distribution of Kubernetes are actually the upstream binaries of Kubernetes.
Yeah.
We don't even rebuild the binaries. It's really just our work is just in the ops framework around that and standardizing that so that it works on every cloud. Yeah. Other questions?
I have a question.
Go ahead, Mark.
The City Networks cloud you deployed, did you containerize the control plane?
So the question was, the City Network Cloud, does it containerize the control plane? Yes, absolutely. That is basically the same approach that Juju is taking. Juju deploys with LXC. OpenStack Ansible deploys services in Juju deploys with LXD. OpenStack Ansible deploys into LXC containers, but it's basically the same approach. With OpenStack Ansible, you do have the option, as with Juju, that you can either deploy to the metal or you can deploy to a container. So that's essentially the same thing. It's only the fact that Juju goes through LXD as the container hypervisor, whereas OpenStack Ansible uses LXC directly. But basically, the approach is pretty much the same. And then there's minute details between the two, like what defaults to running in a container versus what doesn't. But those are really like minor technicalities. But the approach is essentially the same.
Yeah, for those of you not in the know, LXC is a basically like if you take Docker and you extend it to be able to run an entire guest, right? That has the downside that you have more stuff going on in that container and it's messier, but like a VM. It has the upside that you can think about that just like a VM or a machine, right? You don't have to change any of your operating frameworks to do that. And you get the performance and isolation characteristics that you would get with a Docker container. So it's just a slightly different take on containers that's a bit easier. If you've got a ton of tooling to deal with VMs, you can deal with LXDC containers in exactly the same way. Yeah. But I wouldn't be prescriptive about that. If you're Dockerizing stuff, that's fine too, obviously. Yeah. Yes? Maz and Ironic. Maz is a lot, well, actually, Florian, this would be a good one for you to answer.
Okay.
Because I obviously have a view.
Right, yes, exactly. So basically, both attempt to solve the same problem space, right? And I would almost go so far as to say which one of it is better for you is more dependent on like how your organization is built and how you want to deploy than the relative merits of either. Maz is hugely popular because it's very nice, it's very well polished, you get a nice dashboard and everything. And it makes it really slick, and you can do a lot of things, like specifically since about the Maz 1.9 time frame, about that, which is what, a year and a half ago now, something like that, it became really nicely integrated with networking and storage and other things. So that was, it's very smooth and streamlined that way. And it's a really nice way to just deploy things on the bare metal. The one thing that it doesn't support is talking to the metal via an OpenStack API. And if that is something that you absolutely must do, so you want to, for example, integrate your environment, your bare metal environment, into your OpenStack as you do virtual machines, then Ironic is the way to go, because on top of, it has less polish than Maz, but it is more tightly integrated with the OpenStack APIs. I think that's sort of the shortest 30-second answer that can give sort of from the operational considerations point of view for Maz versus Ironic. But we can probably have a 1.5 hour discussion on this and the relative merits.
The short version of that discussion is you should try them both. Right?
It's true, yeah. Absolutely.
What we see typically is people, they have a set of people who operate the data center. And Maz is really perfect for those people. It essentially controls everything in the data center. It does it really cleanly. It's really understandable, and so on. And then sometimes there's a slice of the data center where OpenStack makes sense. And Ironic would make sense to us as if there's a slice of that slice where you want to actually give people bare metal using their credentials and tooling essentially associated with OpenStack. But I think it's fair to say that there are many, many, many more instances of Maz deployed than OpenStack deployed, just because of the relative complexity of the two. Maz, quite pointedly, will not do anything outside of the realm of basically Pixie and operating system deployment and very lean control of that and the networking and storage associated with that.
I think another advantage of Maz is that because it integrates so tightly with Juju, like if your deployment approach is via Juju and you have up to this point deployed everything that you have on OpenStack or AWS, then deploying that stuff to the metal is a breeze because Juju is so tightly integrated with Maz as it is tightly integrated with OpenStack and AWS and a handful of other providers. So.
Maz is now also being used a lot for edge clouds. So if you have only 3 machines or only 4 machines, then it's a very lean way to essentially allocate capacity on those. Yeah. All right. I think that's a wrap. Florian, thank you very much.
Thank you, Mark.
Congratulations.